Okay, so today is the second page of notes. This is actually day 3. Yesterday you just had a worksheet. So today we're going to continue to work with differential equations, but we are going to have a couple of little twists and actually be able to start to solve some different types of problems, not just um, problems that are, there's going to be some word problems and some applications. Okay, so here we go. Our goal today is that you are going to be solving differential equations that require something called separation of variables. But before we even start, up here on top, I am going to make something called a little side note. And this is going back and making sure you remember some algebra rules that we have seen before. So we're going to get problems that look like e to the negative x plus c up here. And I need you guys to remember, and this is going backwards. We always would get this as a solution. So we're going to write it backwards. It came from e to the negative x, and it would be times an e to the c value. So that is something that you need to know. Now, here is what you need to be able to recognize. E raised to a c. We don't know how big the c is, and since it involves a c, we rewrite this as just being a c value. Not an e to the c anymore, just c. And this first term stayed e to the negative x times some unknown, which means this whole thing is going to equal c e to the negative x. So again, I have it raised to a c power. A c, we don't know what it is, so we don't know how big this is, and any unknowns lately, we've been calling them c for the last couple of chapters. So e to the c is just becoming c, and this turns into this. Okay, that's a little side note. So on to the actual types of problems that we're going to be looking at today. So again, y terms on the left, x terms on the right, and this is called separation of variables, and that was what part of our learning target was going to be. So just like we've done before, I see that this has my dx, so I'm going to move it to the other side, and I get dy would equal 6 minus y and a dx. And I all of a sudden see that this is not going to go well because I have some y terms here that I just put in the parenthesis and I underlined x terms. These have got to come to the other side. Now, some of you are going to say, oh, I could add or subtract. No. No adding and subtracting to move the stuff. We are literally going to divide by 6 minus y, so it's a similar type of problem like we did yesterday on the worksheet. So when I do that, I end up with dy divided by 6 minus y would just equal my dx. Now, this is good because remember, we are integrating each of these things. I can easily integrate the dx, that's just going to become x, but this is a fraction. So what are the three things that we think, or right away, I think of the word split. And can I split this apart? No. Bottom to top. Bottom to top. And can I do that? No. So now I'm thinking of, oh, my u value is going to be 6 minus y. So my du value is going to be a negative dy. And I look and I'm missing my negative sign here. So I add my negative sign on the outside. And then what I'm going to be able to do is I can rewrite this as my negative integral. Now notice it's a fraction. The u is on the bottom, so this is a du over u problem equals the integral of dx. oops, x, there we go. So now I'm going to have a negative natural log. My u value is 6 minus y, and it's going to equal x. And remember, we always need our plus c. You can't forget about me. Now, here is the issue. Remember I talked about it yesterday? We need to solve for y equals or y squared equals. I got to get this y out of here. You need to remember that this problem has a base of e on it, and I can rewrite some of this stuff using my log rules. But the first thing I have to do is get this natural log term by itself. So I am going to divide by -1 on each side first, and that means that I'm going to get my natural log of 6 minus y is going to equal a negative x. I am still going to say it's plus c because we don't know if that's a negative or a positive. Hey, we're allowed to do that. So now rewriting this, and again, remember my base is e on here. So using my exponent rules, this becomes e raised to the negative x plus c power is going to equal 6 minus y, which then means if I get the y by itself, I'm going to have e raised to the negative x plus c. Subtract 6 is going to equal negative y, or finishing this up, this is going to become y would equal, so if I move that to that side, I'm going to have my 6, notice it went from negative 6 to positive 6, minus e raised to the negative x plus c. Now, here is what you need to remember. I did the side note. This term here, we are not going to ever leave it like that. We are going to rewrite it and look at what we did at the top. This would become c e to the negative x. When I see this plus c hooked on here, that c is going to come down in front of that e, right, like I did here, and this is going to be my final answer. There's going to be a reason why we're going to change it, and C is going to have a meaning when we get to some word problems. So this is how we do it. So now let's take a look at the next problem. For the next problem, the X is coming over, the Y's are coming over, just like we did before, and I'm going to have dy divided by 1 plus y is going to equal x times dx. And now, all I'm going to do is I'm going to integrate it. Right side is easy squeezy. Left side, can't get rid of that fraction, can't split it. So my u value becomes 1 plus y, which means my du value becomes 1 dy. I've got my dy, I've got my pieces, so I can rewrite this as the integral of du over u is going to equal the integral of x dx. So this becomes the natural log of 1 plus y is going to equal x squared over 2 plus c. Can't forget about me. So now, again, remember, this is a base e problem, this natural log, so we can rewrite this exponentially as e raised to the x squared over 2 power plus c equals 1 plus y. Now, remember this trick here. This has a c on it, so I'm going to get used to rewriting that right away, and I'm going to make this c e raised to the x squared over 2 power is going to equal 1 plus y. Or my y would equal c e raised to the x squared over 2 subtract 1 power, my y value, notice how I'm always putting my y on the left side when I'm done, equals CE raised to the x squared power over 2, subtract 1. And that would be my solution. Okay, now I have some things in goofy order on this one. I want to skip to the back and do one more of these, and then we'll come back to that front one. I want to do this last example, or this middle example on the back page to kind of keep this group together. So for this page here, I see the x is going to come over. Do you see that this y is times 3/4? So I'm just going to move the y over, and I'm going to get dy divided by y is going to equal the 3/4 dx. Now, you could have tried to move that, and then you're going to get extra stuff here. Leave the numbers here if you can. Sometimes you can't. So now I am integrating this, which means, hey, this bottom I can't change. So my u value is y. My du value is dy. So this is the integral of du over u equals the integral of 3/4 dx. Power up each side, the natural log of my u value, which was y, is going to equal 3/4, raise that to the first power, x plus c. So again, this becomes e raised to the 3/4 y, or I'm sorry, x power plus c equals y. Now, remember our trick. If this has plus c in it, that's going to come down. So my final answer for this would be y equals c e to the 3/4 x power. Now, this would have been our equation and our answer in the front. This said solve the differential equation. Okay, this is my equation. So now it's asking through a specific point. This is my x value, this is my y value. So now 10 equals c e raised to the 3/4 power times 0. Anything raised to the 0 power is the number 1. So I have 10 would equal c times 1. C equals 10. So now my new equation is actually y equal 10 e to the 3/4 times x power. Notice this has the c replaced with the value. Very similar to the front, but now just taking it to the next level. So this one is my true final answer. Okay, so now I'm going to zoom back to the front page. Sorry about this, but it just makes it easier because then things are grouped together. And we're going to solve a differential equation. Now, a differential equation, just to make sure that we're all on the same page, means that there's a dy dx, or there's a derivative in it, and then we're going to solve it. Okay, that means I get it into y equals, or whichever variable they call it. So now we're going to examine this statement, and we're going to do exactly what it says. It says the rate of change of p. Rate of change of p means that rate of change, do you guys remember the word problems? dp over and wrt. I know you guys were thinking something else. WRT means with respect to. With respect to t. So this t right here means that it's going to be dp over dt. Now, back to geometry class is proportional. Proportional means it's a fraction. And the word is, you guys know, means equals. So dp dt, the change of rate with respect to t, is proportional. That means it's going to be a fraction to 25 minus t. And what we're going to do is we're going to set these equal to the letter k. K is going to be a constant. We're going to find the constant in a little bit, but we've got to just learn to solve the equations. So proportional means fraction. Okay, so now I have got to solve this equation. I've got to get this dp dt by itself. So dp over dt is going to equal k times 25 minus t. And now look at what we've done before. I've got a dt here, so I'm going to move that to the other side, and this is going to become dp equals k times 25 minus t dt. Okay, so now how would we get the p by itself? Well, we're going to have to integrate it. So when I integrate it, here's the fun stuff. dp becomes p equals. K is where our coefficient would be, so the k just comes down. And when I look at this 25 minus t, I can power up each of those pieces. 25 times t, and that would be over 1. Add it, or I'm sorry, subtract it. Erase. That should be a subtract. T to the second power over 2. And the dt goes away, but then it's a plus c. Okay, so proportional means fraction. So when we go to the back side of our notes, I need to make sure that if it says inversely proportional, we multiply instead of divide. So this is something that you need to know for your homework. Okay, so how is this going to apply to word problems? Okay, this is going to be a 3-part problem. I am color coding. First part is going to be red. And the first part of this problem, and I'm assuming that you guys have read it, says the rate of change of n is proportional to n. So this is going to be my differential equation, dn, change of rate, over dt. Now, how did I know this was a t? You see how they used the t later on? That's what it had to be. So dn over dt, proportional means fraction to n, and that is going to equal my k value. Okay, so I need to know what n equals, just like we did above, or I'm sorry, on the other page. So I am going to work on this a little bit, and I see dn dt is going to equal k times n. Ooh, not good. But we're going to do a little work. This dt can come to the side, the n can come. So I see dn over capital N is going to equal k to the dt power. So all I did is I maneuvered all of those equations like I have in the past. I am going to now integrate them. So I put in my integral sign, and then I get, oh, I hope, can you guys see that my u value is n and my du value is dn? Can you guys see that this is du over u? So since it is du over u, I'm going to have the natural log of n is going to equal, the k value is a constant, and then I power that up, so there's got to be a t. Oops, don't know what that happened. There's got to be a t there, and then this is going to be plus c. Get that n value by itself. I'm going to rewrite this. This is e raised to the kt power plus c is going to equal n, just like we've been working on so far. Remember our little trick here. Oh, my pen is not working. There we go. When I have this plus c, you know it's going to come out in front. So this is really c e to the kt power is going to equal n. Okay, this is what we just finished doing earlier on our worksheet. So now that's stage 1, color 1. Color 2 comes in for the second piece. And this second piece is going to help me solve for C. Okay, so I'm going to take my equation. Oops. I'm going to take my equation, and I have CE raised to the KT power equals N. And now I'm going to plug in CE to the K times 0 power would equal 250. Remember, anything to the 0 power is 1. C would equal 250. So now I know my equation is 250. E to the KT would equal N. Okay, third part of my equation. Now, when T equals 1, N equals 400, hey, I can solve for K. And this is the order that you have to do this in. So 250 e raised to the k times 1 would equal 400. Now, to solve for that k, remember the e's got to be by itself. So e to the k, notice I got rid of the times 1 up there, is going to equal 400 divided by 25. I'm sorry, 250, which you guys should be able to reduce down. I did to 8/5. So I have e to the k power equals 8/5. If I wanted to solve for k, I am going to go backwards and I'm going to introduce, a natural log on each side. And remember, when I introduce a natural log, that lets me get the k out of the exponent because that's where I want to solve for. And I get k natural log of e equals the natural log of 8 over 5. Guess what? Natural log of e is 1. K equals the natural log of 8/5. That is a value. I'm not changing it because it's a big decimal. So now my equation is it's evolved through the time, 250 e raised to the natural log of 8/5 with a t behind it equals n. So I started with my change of rate. I solved for c. Now I solve for k. So all of these are independent. And finally, it wants me to solve it. What is n when t is 4? 250 e raised to the natural log of 8/5. And then I take that value times 4, and that equals n. And I grab my calculator, and when I put it on my calculator, it turns out to be 1,638.4 and 00. And that is when t equals 4. It's a lot of work to solve some of these, and you've got to be neat, and that's why I use colors on this. So tonight's assignment works on some of these word problems, and eventually this is where we're headed with these word problems. So you've got to know the process. That's what we're working on. So good luck on this assignment. I will see you after spring break, and we will work on this one more time.